This case study consists of two separated laboratory, the Lab 1 and Lab 2. Even though they are separated, they are still connected by a router. The Lab 1 has 8 PCs connected to Lab 1 switch, while the Lab 2 has 10 PCs that are also connected to its own switch. Each lab uses a unique IP address. They are connected using copper straight-through cable. The Lab 1 are using IP range from 192.168.1.10 to 192.168.1.17. The Lab 1 use a subnet of 255.255.255.0. The Lab 1 are also using default gateway 192.168.1.1.
Two switches located centrally, these act as hubs connecting multiple devices. A number of PCs are connected to each switch, simulating an end-user devices in a network. Lines represent the network connection between the switches and PCs, likely Ethernet connections. This setup demonstrates a basic star network topology where each PC is connected to a central switch. The switches then might be interconnected to allow communication between different parts of the network. Both PCs are configured with the static IP address within the 192.168.2.0 network. They share the same subnet mask and default gateway. The DNS server is set 0.0.0.0, indicating that they are not configured to use a DNS server. IPv6 is set to automatic and each PC has a unique link local address.
And lastly, we tried sending a simple PDU from PC to PC, PC to router, and PC to PC in the similar laboratory, and which comes out successful.
This is a layout of a physical layer connected to two laboratories labeled Laboratory 1 and Laboratory 2. The router is inside wiring closet, highlighted with a blue border. Green lines connect the closet to the laboratories, symbolizing network connections. It provides a high-level overview of the infrastructure, aiding in planning, troubleshooting, and understanding the relationships between different areas and the central wiring hub. This is the back panel of the router, includes LEDs for system status activity and power over Ethernet availability. The green cable is the wiring that connects Lab 1 and Lab 2. Laboratory 1. Switches operate at the data link layer of the OSI model and are used to connect devices within a network, forwarding data packets only the intended recipient. 8 computers are connected to the switch, 4 on the top and 4 at the bottom. These represent end-user devices or hosts on the network. This type of network setup is commonly used in small offices, labs, or classrooms, providing basic network connectivity for file sharing, internet access, and other network-based services. Laboratory 2. The switch facilitates communication between the PCs on the network. The green arrows illustrate the network connections. Multiple arrows converge on the switch, indicating that all the PCs are connected to it. The single green arrow pointing away from the network towards the left might indicate to a connection to another network or the internet. But without further context, this is just a possibility. In essence, this is a basic LAN setup where multiple PCs are connected to a central switch, enabling them to communicate with each other and potentially with other networks. The switch manages the flow of data between the connected devices. The network may be segmented for better management and security.